The following episode is brought to you in part by Nissan Commercial Vehicles and the full-size NV Cargo. Nissan, innovation that excites.
We've come to the desert, Palm Springs, California, to build our EnergyWise house, and boy, what a place. This is a place of extremes, so it's a place where all sorts of building technology can be put to the test. Steve Easley, who's a building consultant, is going to help us understand some of the materials that are being used here. So let's get started talking about the building envelope of this house, Steve. This is probably the first line of defense against heat infiltration and in terms of energy conservation. How you build it?
This is a structural insulated panel, or it's called SIP. Basically, it's pretty simple. It's been around since the 40s, but this is expanded polystyrene sandwiched between two layers of oriented strand board. And interestingly enough, the oriented strand board is actually stronger than plywood in this application.
So this is all a structural element, and we're just looking at a mock-up here, but you can get these up to what?
8 by 24 feet.
8 by 24 feet.
You can do an entire wall of a house with this.
Get them off a flatbed truck, the
Absolutely.
crane puts them in place, and you can build a house very quickly.
You don't have the typical framing. On a normal home, about 20% of the whole surface area of the home is all the wood parts. With this, as you can see, it's all insulation, and where it gets its strength is that these panels are actually glued to the polystyrene, so it's very, very strong. You can make these floor panels and even roof panels that'll span 20, 30 feet.
What's the R factor here?
This is about R19, Bob.
R19. Now, there are other areas of the house that we'll see where you couldn't build it with a SIPS kind of material. You had to go to traditional stick framing, right?
That's correct. Yeah, the house is very unique, as you know, and so some of the areas just didn't lend itself to the SIPS panels, which SIPS is very flexible, by the way, but we had some other unique framing.
You do have a stick-built frame, you're putting in a different kind of batt insulation.
Yeah, this is made by Bonded Logic. It's basically recycled cotton fibers from blue jeans, this type of thing.
That's right, it's blue jeans, which is what gives it the distinctive color.
And the uniqueness about it is in the manufacturing process. They don't use any formaldehydes or anything like this. Pretty environmentally friendly since it's all recycled materials. But the process is unique in the sense that it gives you a very uniform, strong, as you can see, connection between all these fibers. And what makes it insulate is its ability to trap air. This is about R19.
An R19, but this is not a 6-inch batt. This is just a regular 3.5 or 4-inch batt. Right?
Actually, this here is about a 5.5-inch batt when it expands. It just came out of the package, so it's still a little compressed. It'll grow as time goes on.
I see. Well, that's pretty great. Now, another part of the building envelope that's very, very important and crucial is the windows. And
Absolutely.
When you're building in the desert, you want views, but you also want to prevent a lot of hot air from coming in and the rays of the sun, etc. So my favorite term, fenestration, the location of the windows, the placement of the windows is an important part,
Absolutely,
right?
Absolutely. Well, in this home, most of the glass faces north, very little east and west, but the glass that does face east and west is a real high-performance window. This is a Phillips product. This is actually a triple-pane window, but really what makes it unique is it's got several layers of low-E coatings. And these low-E coatings are called Spectri selective low-E coatings, which they have multiple layers of silver on the glass.
Yeah,
now,
it's low emissivity, which means it's really a low emission rate.
Correct. And what's interesting, Bob, is that these windows block 74% of the radiant energy from the sun. They reflect it. Now, what that means, if you look at a typical house, 1 square foot of glass, about 250 BTUs of the sun's energy strike that glass. So if you had a standard 6x7 sliding glass door, that's almost 10,000 BTUs of energy from the sun that strike that glass. That's a fourth of a typical home's air conditioner. So being able to block the radiant energy from the sun is really job one, because in California, and most homes in the United States, about 45% of a home's design cooling load is just heat gain through the glass.
And if your electricity is expensive, as it is out here, this is very important stuff.
Very, very. So it really makes sense to buy the highest performance window possible. There's important numbers on this NFRC label, National Fenestration Rating Council label, and it's the U factor and the solar heat gain coefficient.
Now, again, getting back to fenestration, here in the desert we're taking advantage of north and south exposures to put in large expanses of glass, capture views, etc. But on the east and west ends of the house, we're putting in a lot of small windows, which allow for small amounts of heat gain.
That's correct. Okay. Lots of natural light, but without the heat.
what can you do with a product like this? This is for touch-up, right?
Right. This is reduces air infiltration. As you know, air infiltration accounts for anywhere from 30 to 40% of a home's energy bills. But what's unique about this product is that most foam products, if you spray it around a window, it expands and
Right.
it causes the window not to operate, right?
Yes.
Because it expands so much. This is a low pressure expanding foam, which means that it's designed specifically for around windows. It reduces air infiltration and makes your home more energy efficient.
Low pressure expanding foam. Good idea. Let's talk about the siding. We got samples here.
Well, you know, homeowners want homes that are comfortable, durable, and energy efficient, and durability is really an important part of any home. This product is a fiber cement siding, which basically it's a cellulose type material mixed with cement, and it makes for a very durable, water, moisture resistant product.
And does it have other advantages from the point of view of keeping the cold air in?
No, not really. The real advantage to this is just a durable product that just never rots out.
Okay.
It's very easy to paint. It holds paint for a long time. So the maintenance of a product like this is
It's
very
very
low.
cost effective.
Very much so.
But then back to my question about keeping the heat out and the cool in, this product, the Tech Shield, is very effective.
Yeah, this is a radiant barrier sheathing, and it goes
It's used
in
for
upside
roof
down.
sheathing, right?
Yes, in the guest house here, this product is applied here. What's interesting about it is that it goes down with the roof sheathing and does very simple application. As the sun's energy strikes the roof, it absorbs that heat, and of course it wants to be re-radiated into the home, which makes the home hot. This product reduces the temperature in the attic by as much as 30 degrees. It can basically provide you about an 8 to 12% savings on your energy costs.
It's a great idea.
And it's got perforations in it so that any moisture that does build up in an attic or a space can, be absorbed and pass through the board.
Great.